Good evening, everybody. Thank you for joining in and being a part of this evening. This is Swapnil on behalf of TCS iON, and I welcome you all to this exclusive free masterclass on deep learning. Today, we are diving into the fascinating world of deep learning, how machines are learning to think, adapt, and solve problems in the way that mimic human brain. We'll explore how deep learning enables computers to recognize patterns, make complex decisions, and even generate predictions. From understanding the basics, like how deep learning modules process data, to real world applications such as image recognition, natural language understanding, and autonomous systems. This session will break it all down for you. Whether you're new to AI or looking to enhance your skills, this masterclass will equip you with practical insights into the future of AI and its transformative power. I'm thrilled to introduce our expert speaker for today. Let me give a warm welcome to Professor Ayan Das. A quick intro about Professor Ayan Das. Dr. Ayan Das is an assistant professor in the Department of Computer Science and Engineering, IIT ISM Dhanbad. He has received a PhD from IIT Kharagpur. He has completed his BTech and MTech degrees in computer science and engineering from NIT Durgapur and IIT Kharagpur respectively. His research interests include natural language processing, machine learning, and information retrieval. Now, before joining IIT ISM, he worked as a system engineer at TCS for 3 years, from 2008 to 2011, and as an assistant professor in Department of Computer Science and Information Systems at BITS Pilani, Hyderabad campus from December 2020 to 2021. And currently he has 16 publications in reputed conferences and journals. A very warm welcome to you, Professor.
Okay. Thank you. Thank you, Swapnil, for your nice introduction.
Thank you. This discussion is just getting started, and we are sure it's going to be both enlightening and inspiring. So let me move on to Ayan sir. Before we begin this exciting masterclass, sir, could you briefly explain what is deep learning and why it's such a game-changing topic in the field of AI today? Over to you, sir.
So, yeah. Thank you, Swapnil. Okay, so to answer your question, that what is what is neural network or deep learning is all about. So first of all, you have to understand that our audience already know that deep learning is about the number of layers. But what is deep learning? So the entire idea is about that to find out a model or computational representation that that we can apply to solve our real world computational problems, okay, using a representation inspired by the working of human brain. So why I am using the term inspired, because actually not a single person in the entire world know that how the brain actually works. But with whatever minimum amount of knowledge we know, we have about the working of human brain and how these nerve cells are organized, and in our maybe has some they're interconnected, and all these ideas we try to put together in order to get a representation which should some sort of behave in the way the brain uses its network or its setup to process data and solve the computational problem. So since we have believed that our brain has enormous computational capacity, so just we want to put it in our application in the form of some. And why artificial? Because we are trying to mimic a natural system. So that is what the idea about. Now, what is deep? Now, deep means that as we will see that in this whole course, that the essential building block of these neural networks or deep learning models. These are the perceptrons or the artificial neurons. We put them together, we form a multi-layer network, and as the volume goes up, as the number of layers goes up, so ultimately the things become like as equal deeper and deeper. So this and this actually helps you to process the data more efficiently. Now these interconnections, and based on the different interconnections that we have or prepare, we and based on the use cases rather, or what in which application or domain we are applying these combinations of neurons, so or the artificial neurons. So there are different varieties. For example, you have the convolutional networks, you have the recurrent networks, and all these types of networks we have. And also, of course, the most basic form is the multi-layer perceptron or feed-forward neural network. So now, where is this game changing is all about? So the history of this entire neural network goes means like it goes back to 1958. So if we consider, if to be exact, so when people started saying that okay, a single neuron can itself be used as a to learn to learn to solve some computational problems. But later on, several people, I mean, like big shots like Minsky and all those researchers, they found out several flaws with that one, and that went into the what we call the winter of deep learning. Now, but after I exactly do not remember the year, but when the backpropagation algorithm, that is the algorithm to train this machine learning algorithms or the neural networks came up, people had also had access to these enormous computational powers. When the computers grew in computing power, people used that algorithm and the computational power of the modern day computers. And after that, this winter sort of ended, and this entire idea of neural networks was brought back. Now, the way we can organize these neurons and and we can scale it. So this is exactly where the power of these neural networks come from. So we can and in the it is actually what we will show in this in the later in this course, that it is the just like a more the more complex the neural network becomes, or the network becomes, it will store in its parameters the different information that is required to solve a problem, and that put together is what makes this particular deep learning stuff so exciting, so lucrative, and it becomes almost ubiquitous. In every aspect of our life we are using these neural networks.
Thank you so much, Professor. You took us back from the origination to the evolution, how it evolved to now, to what it is today, that we use it in everyday life. So that's really a wonderful explanation. I give the stage to you now. You can take us through the masterclass.
Okay. So, yeah, whatever I have, so first I will just briefly again go back to what I did. I will just share my screen. I will present some slides to you. Okay, so and I will try to show some applications. Know that most of our audience knows that, but still I will just try to put the things together. And after that, I will do that very fast, so that and after that I will try to move on to a hands-on session that I will try to give you, where we will look into the aspect of how we can use a Python library to build up this very basic multi-layer perceptron. So I have kept this particular tutorial very simple and basic with the purpose that because maybe many of our audience, I have created it for the majority of the vast audience. So and what I expect from the audience side is that those who are new to this aspect and are eager to learn from it from the very scratch, so they should work along with me, and so that they can start their browser, go to the Google Collaboratory, and where they can write the programs themselves, and then we can proceed, so they can get a hands-on idea. So as I proceed, so at the there I will try to put up the different aspects of the construction, and each of the elements that I will put up. So I think each of these will be a entire class or the point of discussion in the rest of our course. So yes, so shall I share my screen then? So as I started with this discussion, that the artificial neural network, it is actually a representation for solving the computational problems inspired by the working of some brain. Okay, so it is not necessarily human, but any animal brain. So the representation, why I'm calling this representation, because so I will just take some time on this one, because in all these aspects of machine learning, or where we apply learning, so there the element there is a element of computation involved. So computation corresponds to so it is nothing but conversion of an input to some given output. So this sounds pretty simple, but as I will see, as you can will see that in the applications of a artificial neural network, so this setup is becomes extremely elaborate and complex. So for example, the input can be your entire surroundings in the form of image, video, sound, everything, and the output can be the decision of the operations of your car. I am talking about a self-driven car, autonomous vehicle. So this can be the scale of, or for example, it can be the sensors fitted on the surface of an aircraft, and how and that can be that computation can be done, and the output can be the movement of the wings that should be done at that point of time to control the entire aircraft. So that is what I'm talking about, input and output. And it can also be as simple as taking a simple number and computing whether that is even or odd. So this is the entire range of possible things that you can consider as a computational problems. Now, the idea over here is that if you already know the definite steps or in that you can apply to convert a given input to output in finite amount of time, then you don't need any all these neural networks or any machine learning technique. So you can simply write down a program with different steps in any programming language. You can always keep on taking the input and generate the output. Now, the entire idea of machine learning or the deep learning comes in when we actually do not know how to the exact function or how to compute the function that will convert a given input to a given output. So now the more elaborate or more detailed the particular so then what we do over here is that we first of all we consider that, see, maybe I do not know the algorithm, I do not know the function, but maybe I have a model or a representation that can mimic that particular function. So if I give it the input in some way, it will give me the output by mimicking that, by learning to mimic that function. Now, if I already have a representation, then given an enormous amount of data, then from the data, that particular representation can try to learn an approximation of the function, and then once that learns the approximation, then this representation of the which we call the model will then be able to take any input and give me the desired output. So that is why we are calling it representation. Now, the neural networks here, the representation is inspired by the working of the brain. So why I am again, I just told what inspired means, so I will not repeat it. But here the idea is that just like the brain is composed of several smaller units or cells, which are called the neurons, so that you can see in the left hand side of this diagram. So also we try to capture it in the form of a simple unit which we call the perceptron. So a neuron in real life or a biological neuron is approximated or mimicked using a particular type of function called the or type of element which is called the perceptron. Now, since the basic working of a neuron is like this, that it collects the signals, incoming signals through these connections called dendrites from the other neurons, and then process the data in this inner portion, and then it and give throws the output through this connection called action to the other to the downstream neurons. Similarly, here also the idea is like this, that we will present the input in the form of vectors. This x1 to xn, this is a vector where each of them is a corresponds to dimension, and will take a weighted sum of all these inputs in this sum, and after that we will have a function. That function will we apply a function on that particular sum and give the output. So essentially, the working of a neuron is approximated by a uh, perceptron in these two steps. First of all, you get the input, compute the weighted out sum, and then apply a function on top of that one, which we will call activation function, and give the output from this particular result. So in the most basic form, so what we need, why do we need these weights? So the weights, you can consider that what is the importance that you give to each of these individual neurons or the input elements. And ultimately this activation function in its most basic form is a threshold. That is, if the sum is beyond a certain value, then above a certain value, then you say that okay, we use the term called firing. We say that if the value of the sum is greater than a threshold, this particular neuron or perceptron fires. Otherwise, it doesn't fire. So this is the most basic form. And again, I will this in the example. For example, you are trying to purchase a mobile phone. Now you wish to decide whether, given a particular mobile phone, you would like to purchase it or not. And your decision is based on these three characteristics. For example, network service, camera quality, and the processor. Now, in this particular case, this W1, W2, W3 are the network. So as I was telling you that this is so these are the elements that we now we decide. Now suppose we have higher weight on the network service. Maybe if you are okay if the camera quality is not so good, but you are very much particular about the processor. So of course this W1 W2 will be high and W2 will be low as compared to W1 and W2. So these are the relative importances that you give to the different inputs while you take a decision whether to purchase the given mobile phone or not. So this is how we can just more or less try to think about this element of perceptron. Now, if this, so now what happens? Suppose you suppose you this network service you quantify with some value, the camera quality and the processor. You take the weighted sum, and if that particular sum is above your expected your threshold that crosses your satisfaction level or within your satisfaction level, you accept it, buy it, otherwise you reject it. So this is like the firing of that particular perceptron. Now, so this particular thing I will just state here, but in the course we will go into details of this one, that the perceptrons have very limited processing capacity. So even and we will see that there is something called linear functions that only that it can solve. But the actual wonder happens when several perceptrons are put together. Now, in this entire course, I can briefly tell you that the entire course will be about primarily these two things: how to organize the perceptrons for a given application and how to make them work together optimally for a certain task while you making use of the available data. So these are the two questions that we will trying to answer throughout the entire course on deep learning, and this is what is about the deep learning engineering. So if you know how to which organization of perceptron to choose, how to choose them based on the data, your application, and how to train them. Okay, so how to train them to get the work done. So they are like dragons. Now, if you have to train them. So now here, if you optimally train them, so then they can work great things for you. Okay, so this is a basic connection that I was talking about, how to put these things together. So this is called a now a single perceptron may not be maybe weak, but several perceptrons when put together uh, are quite powerful. So here, how this is the diagram of a multilayer perceptron where there are several perceptrons organized together. So these are individual. So these circles in blue, orange, and red. These are the individual neurons, and here every neuron has some input connections and there are the output connections. So the outputs of the neurons move on to the outputs of the following layers. So these are the layers. So the leftmost outermost layer that through which the neural network takes the input is called the input layer. The output layer, of course, the name is output layer, from which we get the output, and the internal all the in layers that lies in between the input layer and the hidden and the output layer are called the hidden layers. Now, our in the end around the weights, of course, of these interconnections, those we call the parameter weights, and this is actually the parameters weights that we wish to learn. Okay, so given based on some data to solve a particular problem. Now, this is the basic type of neural network that I have already told you, and based on the application, we can have several different types of neural networks. So I have put up some of them, and there can be many. For example, this is the example of a convolutional neural network on the right hand top corner side. So this particular convolutional neural network is the standard for application in computer vision. So you think of computer vision and the fundamental blocks are the convolutional neural networks. Similarly, when you are trying to model some protein structures or maybe social network graphs, so there we have the graph neural network. So this is the example of a graph neural network. Similarly, when you are trying to model some sequences, for example, you are going for stock prediction, you are going for any most of the natural language processing elements, tasks and everything. So there is a recurrent neural network and the transformers. So as you know, transformers are currently the basic building blocks of any of all those GPT, Chat GPT, and most of the large language models. And on the right hand side, we have example of GAN, or generative adversarial network, which is used to generate artificially or synthetic data. Given from it learns the data about the data from the real-time examples, and then generates new data elements based on this data that it has already seen. So these are the different variations of the neural networks depending on the application where they can be put in. Okay, so these are the applications that we have, like facial recognition, autonomous vehicles, and in medical imaging.
Shri
And
Panisha, we have your question. Over to you, sir.
yes, yeah. Medical image processing. So here you have we can go for this cancer and diagnosis, the diabetic retinopathy, and these are the very challenging areas and the promising areas in which works are going on. In natural language processing, we have the voice assistants like Gemini, Alexa, and you are using Chat GPT, and the entire bunch of use cases that we have, like content writing, email marketing, analytics, training and education, your social media management, everything. Lots of things can be done using ChatGPT. So also machine translation is a big application where still work is going on, and is a very live area of research and also application in natural language processing, where we can apply deep learning. So another example is sentiment analysis. So the thing might sound simple, but there's an enormous application in the area of social media platforms, e-commerce websites, management. And then we have the supply chain and logistic management, and so predictive maintenance, inventory management, warehouse management, supply chain planning. Everywhere there is an application of AI and deep learning. Also, we have the recommendation systems and personalized recommendation systems, where given a particular the profile of a person, we all uh, the websites always try to find out the products that are most suitable for that particular person based on the previous history of the person, the sequence of the set of movies that person have watched so far, or maybe the products that the person have used. Similarly, we have the idea of stock price prediction, where you can have entire networks for that actually analyzes the previous market trends, and based on that one, it gives you the idea about gives you the does the stock price predictions. And also specifically cyber security, by detecting malwares, fraudulent activities can be done using the deep learning techniques. Also detecting attacks by tracking network traffic and anomalous behaviors is also another big application domain of the deep learning. So as you can see, I told you that this deep learning again is ubiquitous, and it is very so it will take a huge amount of time to enumerate exactly what are the different applications. So more or less I have tried to put together the different applications where you can apply deep learning. So you can see that the field or applicability of deep learning is enormous. The prospect of deep learning is enormous, and it is only growing. And and you can always try to grab the opportunity to be a deep learning engineer, and that you can contribute in the industry and also in academia through research. So, and also the generative AI applications you have, where you can do the lots of things: art and design, music composition, content creation, financial forecasting, even in healthcare diagnosis, prognosis, fraud detection. So these are the enormous domain where you can apply the generative AI. We have generative AI applications. So under this entire course, we will cover these elements that we have decided in this particular program, that we start with the basics, then perceptron, details of multilayer perceptron, CNNs, generative models, graph networks, and recurrent neural networks, transformers. So, and of course, how to train them, that entire discussion we shall have definitely along with the hands-on sessions covering each and every aspect of these elements. Yes, so after that we will start with a small hands-on. So over to you, Ms. Swapnil.
Thank you so much, Professor Ayan. So, what I believe is there's something for everything in deep learning. It's, as you mentioned, that it's an enormous and a vast, prospect to look at. There are so many things that it touches upon. We've got a few questions, and that too intelligent ones. So I'll just read it out to you, sir, if you would be kind enough to answer those. So, first question that we have from is Shri Panisha, and the question is, how are transformers made?
Okay, so how are transformers made? So at this, I don't know what's the level of your understanding of this of, of deep learning, but transformers. So I will just go back to the slide. I think
Sure.
if you have okay. So here the picture is a bit hazy, but here the idea is that there are several internal layers. So first of all, it has a layer of embeddings. Embeddings means the representations of words. Then these representations are processed through an element called attention or multi-head attention. So multi-head attention, we'll discuss later, but you have to first you have to understand the concept of attention. So attention essentially means that when so given a particular sentence, so in that particular sentence, what is the effect of the rest of the words on that particular word. So if I talk about from the perspective of natural language processing, so then we try to, that is called the self attention. That is, within a particular sentence, you have a particular word, and what is the influence of the other words on that particular word. So this is what we try to compute. And in this way, we try to and we combine the representations at every level until we get a until we maybe for 12 to 13 times we do this computation until we have a representation that to some extent strongly captures the occurrence or the relationships between the different words within that particular sentence. So, so now if you individually consider every word, so they can have different meaning. But when you put a word in some context, so then the meat has some specific meaning. So now if you keep on processing them, so you will ultimately get a representation for the word, which is called the contextual representation, which means that what is the representation of that word not only by itself but in context of all the other words in that particular sentence. So once we get this representation, then we just try to provide that as a representation for the other downstream NLP tasks. It can start from part of speech tagging, ranging up to question answering or summarization. And
That was so wonderfully explained, answer. Thank you so much. We've got another question from Asha. Why is having multiple hidden layers in a neural network?
okay, very good question. So that is see. So according to there is a theoretical result, and it can be, so if you take the course, I will definitely show you exactly that it can be shown that you do not need a large number of layers. A single a neural network with single hidden layer can solve any of your computational problems. But the catch over here is that nobody says how large that but or how many hidden layers should be in that particular layer. And if you actually look into the real-time problems, so this layer will be in a single turn enormous. Okay, so it's not possible to handle that much. But if you break down that thing into multiple layers, then it can be shown mathematically that um, you can actually capture the similar amount of almost comparable amount of information, but with a controlled size of the controlled number of hidden units in each layer. So that is the reason we use multiple layers instead of having a single layer. So if I'll just give you a very simple example, I think it will be clear to you. So if you take an input size, or if you take Boolean functions and actually your inputs are only zeros and ones. So if your problem is of, say, if your inputs, number of inputs you have is of size 2, then actually you can use just 4 neurons to solve any Boolean function. Similarly, if your input size is 3, you need 8. So as you understand that even for solving the Boolean functions, the number of single hidden layer to solve that particular problem will go in the range of 2 to the power n. So beyond a certain point, it will explode like anything. So just to control that, we instead of using a single hidden layer with enormous number of hidden units, we break it into layers and we go for deeper and deeper layers, networks instead of a single large hidden layer.
Thank you so much, Professor Yan. So we've got multiple, questions that are coming up from the audience, which means they are attentive, they are listening. That's really nice. We won't be able to take all of your questions because we've got the hands-on session that Professor Ayan wants to take you all through. So just be attentive about this, and over to you, Ayan. So you can take them through the hands-on session.
Okay. So in the hands-on session, we will primarily be looking into a very simple construction of first I will show you how to use the Google Colab, because that is where we will be developing most of our applications in this particular course, and then how I will just show you how to use the TensorFlow and the Keras library to develop one small neural multilayer perceptron, and how to classify the different classify the uh, data into different classes. So the data that we will be using for this particular, for our hands-on session, is the MNIST data set, that is freely available, publicly available data set. It is essentially a set of handwritten digits. So and the task is that your system will take the representation of the handwritten digit, or the pixel values of the handwritten digits as input, and uh, the handwritten input, and then what we have to do over here is that we have to but the task is that the neural network will give you the output and which digit it is. So in the range from 0 to 9. So there are there are 10 classes, and the input size will be of say at the around of 274 or something. We will see exactly. So it is the size of the number length cross width of the image. So without further description, let's go into the class. Okay, so that okay. So I will just recap once. So first, you can directly go to the Google, and in your browser, and type Google Colab. So once you are in this Google Colab, so you can click the first link. It will take you to this and it will ask for a um, new notebook. So on the left, if you look into the left hand side, you will see that there is an option of plus with the with it is written as captioned as new notebook. So you please click the new notebook. Okay. So in this Google Colab, there is a facility that either you can actually add a code, or you can add some text to it. Okay, so this is how the things work. So the text portions we can add to keep a track of exactly what the code is about. You can write elaborate comments. It also supports diagrams and pictures, and in the code part you write the the code that you want to execute. Now first you can see that there is a arrow button over here. So this arrow button on the left hand side, that is called the run cell, or if you click it, the entire program written inside this particular cell will be executed. So if you are doing this for the first time, then you have to write, or you have to first install TensorFlow. Okay, so for that one, you can just in your notebook you can type this command, that one exclamation symbol followed by pip install TensorFlow. Now once we have pasted this, we have to run this particular program over here. So once you press run, so it will install the TensorFlow in your in this particular environment. So and you will get this many number of large number of output messages, which will essentially mean that your TensorFlow has been successfully set up in your in this particular project. So otherwise there will be some error messages written in red color or something. Okay, so since there is nothing is there, so we can assume that this thing has worked properly. Now if you want, so this particular set of messages is too much clumsy, so I want to just get rid of these messages. So for that one, you can simply click in this particular button on immediately below the to the left hand top corner of this one, and here you can just press clear selected outputs. So if you clear this one, this entire thing will be gone, but the output, the effect will remain, that is the TensorFlow will remain installed in your system. Okay, so now here what we will do is that, so first then we will try to so we'll talk about these things, that it is so it will have 3 layers, and we will learn the parameter weights. So now once we have done that one, so now we have to import the TensorFlow library. Now TensorFlow is a long thing to type every time, so it is we are abbreviating it as TF over here. So that is what we are trying to say, that you like hash include in C programming. So import TensorFlow as TF, and from TensorFlow.keras.dataset. So this is a so essentially the Keras library also already has the dataset inbuilt. Just you have to import it, the MNIST dataset in it. It's a standard dataset. So you have to just import it from the from that particular datasets. So you just type in over here. You can type in you add. So after this one, you can add a code over here. You will get another block for code here, and then you can type these 2 lines. Import TensorFlow. Okay, so what I will do over here is that.
So while you're typing that, Professor Ayan,
Yeah, I
Anshika
just.
Chaudhary, yeah,
Mhm.
she has a question. Can we use any other app for this?
Any other app in the sense means apart from Google Colab?
Yeah,
Yes, if you already have some your IDs installed, then you can of course use them.
wonderful. Thank you so much.
Okay, so ID means your like some any Python library, you can Spider or something, you can use that.
Right, right,
So, but in that case, you have to manually install the pip or the Python TensorFlow in that one.
right.
And Google Colab, one of the nice thing about Google Colab is that it provides very seamless interaction with the libraries and the data. So every time we do not have to, or if you try to manually install them, then my suggestion is that you can use an alternative like package called Anaconda. Okay, so you can download it. You can just it is a script. You can run it. It will automatically install the entire Python in your yeah, that thing.
Wonderful.
Okay.
Thank you so much, Professor.
So now I'm just typing the commands in the chat box. Maybe if you want to copy them, you can do it from here also. So this is the set of commands that you have to. So is the chat visible?
Yes, it is, Professor.
Okay, so you can copy this one. Um, Okay, so TensorFlow version, it is like there is nothing specific. So you can, the current standard is Python 3. So you can install, that is why I'm telling you that you can download Anaconda, latest version of Anaconda, install that, and you can follow the instructions. So it is a very well maintained package, so you don't have to worry about the version. So you just install Anaconda, the package itself will take care which version of TensorFlow it will you have to, it will install in the system. So everything will be managed by Conda itself. That is a version management tool itself, and it has much more to it, so you can use that one.
Thank you, Professor. And we can continue with the masterclass.
Yes.
We'll take up the questions probably later
So
because
this
we are
is
short on time.
so now once we have this one, then you run it over here. Okay, so once it has done, it has successful. Now you add one more code over here. Now once you have this code running, then then we will load the data. Now see, the X train is the training data, and X test and Y test are the test data. Since this is a supervised learning, so therefore we need both the value or the data as well as the label. So the labels are stored in this Y train or a Y test, where these labels actually say that which digit is that one, and train says that is actually the images that we are working with. Now you can simply copy this particular data from here, and it is actually loading the data. So you can type it in your collaboratory over here. Okay, and if I run this particular and now you can run this one. Okay, so just yes. Now see, it has downloaded the data from its repository, and it has so this is the size of the data. Now see, this is a very important integral component of the of any while you are working with the data. So once you have loaded the data, so just instead of directly jumping into training or something, we should try to have some basic idea about the nature of the data. We should try to visualize it. So visualize in the sense that what is the nature of the data, how should we, what's the dimension, so everything in deep learning is a sort of a matrix. So it is all about how good are you in handling the matrices. So matrix operations, if you are good in, so you are good in understanding the operations of the deep learning programming. So here you have to first see that one, okay, now we have got the data, but what's the nature of the data? So if this is the command called shape over here, that will give you the dimensions of the matrices. So let's check the dimension of the training data and the test data. So you can just copy and paste it in your in the another piece of code and then run it. So see here that we have in the training data, we have 60,000 data points, each of dimension 28 cross 28. So this is the size of the length and breadth of the each image, or it is 28 pixels cross 28 pixels. Now, the next step is very important, where we are actually trying to normalize the data. See, these images are grayscale images. So the value of each of this point is varies between ranges between 0 and 255. So if there is a huge variance in the feature values, then the high values of the features might impact the uh, might hamper or overshadow the effect of the other elements. But to keep the essence of the data while reducing the impact of these high value elements, so we follow a technique called normalization. So there are different ways of normalization. We will discuss them later in the course, but here we are using a normalization where we are trying to bring the elements in the range of 0 to 1. So all the values will be brought down to the range of 0 to 1, but the relative scales will remain fixed. So for that one, what we are doing, we are dividing each and every element by the highest value, so that every value comes down to the range of that 0 to 1. So then this is the normalization process. So you can just take another code, run it over there, and then you will get the normalized data. Now, once that particular data is done, then the next step we do is that thing called train dot reshape. So in this train dot reshape means that, see, it is a so if you look into this one, so the each of this picture is a two-dimensional element. So it has 20, it is 28 cross 28. But in our input we need a we will give a vector that is a single dimensional element. So we have to convert this two-dimensional element into a one-dimensional element. So for that one, what we are doing, we are using a function called the reshape. What it does is that it converts this 28 cross, they combine this 28 cross 28 into a dimension of 784 pixels. So they align the entire thing into a single array, and the rest of the things -1 implies the rest of the elements remain same. So if I run this one, this reshape, so you can first run this, and after that we can look into the interpretation of this one. So what's happening? So initially over here we had 60,000 cross 28 cross 28. Now once you have reshaped them, so then if I again try to see the shape of this one, or you can copy paste these two statements once again over here, or I will just copy and paste it for you over here in the chat. So if you do this, you will see that now the dimensions, the 60,000 the same, 20,000 is same, only these elements have been merged into a single dimension 784. So once we have the data ready, so then the next step is to create the model that we are so eagerly waiting for. So the model, first we are saying that we will construct a sequential model. Okay, so sequential model in sense that it will be the input will start from the left, it will move towards the right through the different units, and you will get the output. So in a very broad sense. Now here what you are doing, so first we have to add the input layer. So these statements are pretty straightforward. Now once we have defined the structure of the model, then what type of model it will be. So now we are inserting the layers one by one. So what is the input layer? The input layer is the shape, its shape is 28 cross 28, means that the input dimension is of 784. So that is the number of units in the, that is the size of the input element, that or the input that we will be giving. Now then what we are saying is that we are adding one hidden layer whose size is 128, and we are using a thing called activation is ReLU. So now I told you that, see, in the working of a perceptron, so there are two components. One, we are taking the sum, and after that we are applying an activation function. Now in activation function, I told you that you give a threshold. If it is better than that, then it is okay. If it is less than that, then it is will not fire. Otherwise it will fire. But the problem of thresholding is that you cannot differentiate it. And if you cannot differentiate it, then it is literally very difficult to train a model. So instead of having this type of non-differentiable threshold function, we use some functions which are to some extent differentiable. Okay, either it is completely differentiable or to some extent differentiable within a. So here ReLU is one such function which is which is not completely differentiable, but we can have a subgradient that we will see later. But so what is the nature of the ReLU? So the ReLU says that if the output of a or if the sum of the weighted sum of the inputs is less than or equal to 0, it will be 0. If it is greater than or equal to 0, greater than 0, then it will be equal to the value itself. So if you look into the example, that for example, if these are the values that you are taking as input, say -5, 2, 9 and -1, then ReLU will give these outputs, that is -5 less than 0, so this is 0, 2 is greater than 0, so 2, 9 is greater than 0, so 9, and -1 is less than 0, so this is 0. Now, I will just paste this whole entire element into your into the chat box that is for you to copy. And so this is the idea of the ReLU activation function that we add to this particular hidden layer. So there are two hidden layers, but we will be using single hidden layer. Now, once we have this particular hidden layer over here, so then what is the next thing? So we have the model, we have the data. Now we have to train it. So for training, will be so for how to train it? So we train it. We use a thing called loss function. So loss function is nothing but an approximation or an estimate of the amount of error that the particular model is doing on a given amount of data, and our objective is to adjust the parameter weights so that the amount of error is reduced, and as an extension the loss function is reduced or minimized. Now here we will use a loss function which is called the sparse categorical cross entropy. And while we do this thing, so this minimization cannot be done in a single shot. It has to be done iteratively. And this iterative reduction is carried out by a thing called optimizer, here we will use a thing called Adam optimizer. This Adam optimizer is a thing which uses the gradient of the function, and that is why we are using the ReLU instead of some gradient based element. So, that is up to the loss function, and in the output layer, or at this particular output layer, we would try to predict that what is the digit that you have, or handwritten digit that you have given us input. Now, for that one, we have 10 classes, and here we use a thing called we use a thing called softmax function. So what is softmax? How we are using softmax? Now, softmax is a function that converts a sequence of values to a probability distribution. And so essentially what will happen is that, so the outputs of these layers will be, for example, some values that will be coming out of these outputs. Now we have to compare them, but they may not be exact probability values. So once we get the values that are coming out of this last layer of hidden layers, then we put them together and we convert them into a probability distribution. And then what we do, we predict the class with the highest probability as uh, the class of the input layer. So here, so the digit for which we will have the highest probability value in softmax, we will say that this particular input image is actually of that particular digit. So how we are doing it? So first, we suppose, for example, we have these four values. Now to convert them into the probability distribution, what we do, we compute the exponent of all of them like this, that e to the power 4 is this value, e to the power 2.3 is this value, like this we compute them. Now once we have them, we take the sum of these exponents, that is coming to this one. Now probability of the first element is the exponent of that one is e to the power 4 divided by the sum. So you divide each of these. Sorry that there was some interruption from my side, and
Yeah, that's
now,
absolutely fine, Professor.
okay. So I will just add the chat over here. Okay, fine. So here we were just trying to find out that values. Now once since we have decided that we will be using softmax activation function, and we will use function, so that we are writing over here that loss function is equal to TF keras losses sparse categorical entropy. And so see, whenever we are doing machine learning, so we have to remember this foundational idea that our objective is that our objective is to train the machine learning algorithm based on the data so that it performs better and better on some task with respect to some evaluation measure. So, for example, we are learning something and we have to write exam every time to show that whether you are learning or not. Hmm. So, and you are based and we are evaluated mostly on the either on the base of score or the extent to which we are able to develop some project or whatever it is. Now, here also we will similarly we will test how our system is performing on a some given amount of data. So here that metric will be accuracy. So how accurately it is able to tell that which digit it is identifying. So these two things we will mention after that. So you can open a piece of code, a code block, and there you can paste these two uh, definitions. That first we will be using sparse categorical cross entropy as our loss function and the accuracy as our metric. Then after that we will first, so what are the things that we have put together? So let's summarize. We have the data, we have a description of our model that we want to train. Then we have decided that okay, the activation function should be ReLU, the metric should be accuracy, the loss function that we are trying to minimize is in terms, or we are trying to measure the performance of our system is the sparse categorical cross entropy that we want to minimize with as we train the model, and we will be using Adam. So this Adam optimizer, as I told you, is a advanced gradient based method that we will discuss in details in the course, where we will talk about the gradient based techniques, such as we will start from gradient descent and what is the theoretical aspect of that one and how we can advance it to more higher elements like AdaGrad or Adam, like these things. So now having said that, we put everything together, and that is where we say model.compile optimizer, where we are using Adam. Loss is the loss function that we have already defined, and the metric is accuracy. So this, if you write, it implies that we are putting everything together. Now we are ready to train the model using the data. So first I will run this portion and then I will run this one. Okay, so let's see what is the problem with this one. Okay, so yeah, so now it's done. Okay, so once it is done, then our only task remaining is to model.fit. Now in model.fit, internally it does the everything. So iteratively it will, so what we have done is epoch is 5. So it means that we will run this algorithm 5 times and update the based on the loss value. We will try to update the parameters so that the loss function is further reduced, and this attempt will be done 5 times on the entire data set. So 5 times we will go through the entire data with our objective of reducing or minimizing the objective function. So this is model.fit. Now one thing that I would like to tell you over here is that this is a very simple example where we are doing the model.fit, but in the course we will this of course we will see, but along with that one we will cover a thing called PyTorch, where we will actually see, we will try to construct this fit portion, where we will see that what exactly goes on inside, how do you set the forward movement of the data, how do you set the backward movement of the gradient, that is the gradient descent or the basic fundamental learning algorithm for any deep neural network. But here we are, for the brevity, we are using the simple function of model.fit. It will do the entire task for us. Okay, so okay. See here in the first epoch it is running and it is taking some time, and it is saying that as we are training, the accuracy is going up. So and loss value is decreasing, so it went out over here. Now it is second epoch has started, so it is going on in batches. So with every batch there is a change in accuracy, and also there is a change in the loss function value. So in the third epoch, so there will be some updates. So this training process will take some time. That's why I have set it to 5 only. Okay, so now you see that the 5 epochs have run and the final accuracy on the training data is 98.77 or 0.9877. Now, once we have done this one, so we are after that we are going for the okay, so if I have not pasted the model.fit over here, I am pasting it once again. Uh, so now once the model has been trained, so we will use this model to test the performance on the uh, test data. So for that one, we are saying model.evaluate, and this we are the results we are storing in test.loss and test accuracy. So loss will store the value of the loss function, and the test accuracy will store the accuracy. So if you just paste it in another code block and let me execute this one, so it will be something around, yeah, it's 97.6 roughly. So this is the test accuracy for the of the model trained model on the test data. So this is the entire so this is what I have shown you is an entire sequence of steps that you need to do when you are training some machine learning algorithm. Prepare the data, prepare the model, set the elements of optimization elements, and finally you train the model and you get the test the accuracy. So there are several things said, a lot of things are unsaid. So how you can set the learning rates, there are a huge number of parameters that you will be that you will come to learn, so as we discuss in the details of the course. So yeah, so over to you, Swapnil.
Thank you so much,
And,
Professor Ayan. So, Professor Ayan, with your permission, I'll quickly address a few questions that I have in chat.
sure.
So first question that I have was from Jacob. Jacob, you want to know if this is the same course, the AIML course with IIT Kharagpur? No, this is a course with IIT ISM Dhanbad, and you can check. It's an artificial intelligence, AI, and emerging technologies. The link has been shared in the chat. You can have a look. There was another question from Abhi. Abhi, that's a really good question. You wanted to know if what time of the day would this course be, or when will the sessions be held, because you're in Eastern Standard Time Zone. So let me tell you this, and also there's a question, if that I'm a working professional, will this course be, it'll only depend if depends on the timing. Shubhankar, you said it depends on the timing of the course, because you're a working professional. So we've designed this course keeping all of that in mind. There'll be two sessions every week, each session lasting for 90 minutes, and this will be in the evening. So we've kept that into consideration, saying that in case if you're a working professional, this sessions will be in the evening, and you all can attend that. Even if you're a student, you all can there'll be two sessions every week, so that will definitely help you. And there was another question, I think it was from Abhishek, if I'm not wrong. You wanted to know, Ajay, the cost of the no cost EMI duration, is it 12 months or 24 months? So Ajay, this is for you and for everyone. You're absolutely right. There is no cost EMI available for you all, and you all can choose from 6 months to 24 months, anything that you all can choose, and that is a leeway that you would get to pay the amount. And apart from that, there was another question, if there is any discounts for TCS employees, from Deepak Joshi. Deepak, as of now, there are no discounts, but in case if there are any discounts, we will surely communicate via email. So please be attentive on your email. So that's about that. If you all have any more questions, please type it in the chat. Siddharth, you want to know, is it free? It's not free. The price of the course is 30,000, and but there is no cost EMI available. Like I mentioned, this is a 9 months course. So everything that you all saw Professor Ayan teaching you all today, this is just a sneak peek. You all will get an entire deep learning about the different domains that you all looked at. And I'm sure by the end of it, you will definitely have enough knowledge, enough experience to probably get a bigger package. And yeah, so Abhi, you said thank you for your answer. Awesome. Thank you for acknowledging, Abhi. Means a lot. Murtuja, you want to know if there is any placement for this course. So once when you complete the course, you will get 3 interview opportunities. That's one thing that you all will get. You all will get 3 interview opportunities. You all will have to clear that. You all will have to get a good score throughout the certification course. 70 marks and above is what we are looking at, and you will get an option to uh, interview opportunities, and then you all can probably check for that. Vino, should we so Professor, we have a question from Vino. Should we have a Python knowledge to attend this course?
Mm. So basic Python knowledge is expected, but yeah, we will give some brush up program, I think, that so that where you can have some knowledge. And one thing is that the course has been designed in such a way that you will learn Python, the elements of Python that are required for this course progressively. So when we start with our basics of mathematics, so there we will start with NumPy, and we'll keep on, then we'll take some idea about machine learning, basic machine learning libraries, and this way. So as you, if you join this course and if you progress with the different modules, then I think you will develop the knowledge that is required for um, developing deep learning models. But yes, if you have some background, do some background study, that will be beneficial for you.
Right. And this is a question from Arpita, Professor Yan. What was the motive behind what we learned today?
So the motivation is about that exactly what is deep learning about, and in a very short amount of time, I wanted to give you an idea that how the what is the development cycle for a deep learning model will look like. So this is a very minuscule example. So it seems very straightforward, but in the course we'll be looking into the details of each and every component that I have shown you today. So each of this line that I initially told you, that is lines that I have typed out in the chat box, and you have also done that one. So that require at least 2 hours of discussion, including hands-on. So just it was to give you a glimpse of what we are going to do in down the line in the entire course.
Right. So, Abhi, you have a question. Whom can I contact about or interact about the program? So, we will again post the link for the program, the certification course. Just click on it. When you scroll down, you will get an option where it will say, whom to contact. In case if you have any doubts, any questions, you can write to us as well. We've got our email ID. All your questions will be answered. Arpita, you want to know in which role IT sector can we learn or use this module? Over to you, Professor Ayan.
So in IT sector, I think I have already means listed down an enormous the prospect of
Correct.
elements. So you can so whichever. Okay, so again I will tell you one thing, that as of now in current date, in every domain there is an application for deep learning. So you can put them into business analytics, you can put them into in designing the supply chain management system, you can apply them in different aspects of the e-commerce, and to automate with your code writing. Even I can even if you want to develop a system where you write a code, and you can try to just get your codes commented, an application that also you can do using deep learning, of course with the help of some pre-trained large language models. You can, for example, come up with an application, maybe that you can give a code, it will get the comment generated for you. So just some these things. And also you can so it depends heavily on the type of domain you are working on. So exactly it's not possible for me to list down everything, but yes. So you can think of any application, take up any domain, think of an automation, and you can just try to do that using deep learnings.
Right. So she also acknowledges Professor Ayan. Arpita says, "Thank you, sir, for clarifying my doubts." So that's really nice. Ritvik wants to know, is there any preference to join this course? Ritvik, in what sense are you asking? So we just want you to have basic knowledge of Python, maybe foundational understanding of mathematics, algebra, probability, statistics. That's what we want you to have. and we want you to have a passion to learn. That's the most important. If you want to learn, I'm sure we've got professors, we've got industry experts who are there to teach you. But ultimately, it's up to you. How do you want to learn, and how much do you want to grasp it? So that's up to you. uh, Also, we've got this question from Mohammad Golam. He says that I'm transitioning from my career, that's civil engineering, to data. I have left my previous job to focus on this course. Will this help me in the future in securing a job?
Well, so doing a course, of course, I don't know, means like it's if you have a holistic knowledge of the basics of deep learning, so you have an enormous prospect in the job market. So that is the general statement that I can give you.
Right.
But see, you have said that what I understand is that if I understand the question properly, then you are saying that you have a civil engineering background, so whether you have any prospect in data science.
Correct.
So see, the thing is that what the direction in which the entire domain of deep learning is moving, the objective is becoming somewhat like this, that you should have more domain knowledge. You do your you apply, so if you are an expert in a particular domain, you have some you will have some prospect in this domain. So deep learning is, or the artificial intelligence is there to automate the tasks, the additional tasks, but the problem definition, where you want to apply them, how you can efficiently solve them, feature engineering to problem planning, and what all architectures you can put into. So all these things can be better done by a person who has a good domain knowledge. So that is the hybrid setup, that if you have knowledge of deep learning, if you have knowledge of a specific domain, for example, let me take you the example of civil engineering. So suppose you are trying to do some say you are trying to working on a problem, you will be able to build some construction in the middle of some say in the middle of ocean or somewhere, maybe where you are trying to do some oil drilling, the structure infrastructure you want to set up. Now given the different aspects of the water salinity, the quality of the sand or the seabed at that point, at that place, there is an enormous chance of prospect of applying the AI techniques to determine what sort of structure you want, what should be the materials that you should use, and all these things you can use them, where you can apply the deep learning stuffs to get automate this process and get your answers. Okay, so that is the, so I am not an expert in civil engineering, but you will be the better person to apply in AI in your domain in using deep learning. So that is what I am trying to impress upon you, that knowledge of deep learning is not enough, or machine learning is not enough. So you should also have a person with a deep understanding of a particular domain. It can be any branch of engineering, it can be computer vision, it can be language, or it can be business, whatever it is. Always have a prospect if that person learns this idea. So you have to use these techniques, or the deep learning techniques, as tools, and then apply them to solve the problems in your domain. So this is the thing that I can tell you.
That's wonderfully explained, Professor, and thank you so much. Let's quickly move on to the quiz that we have in store for you all. So let me quickly put on the first quiz question for you. It says the purpose of the activation function is to dash. So you all see that on your screens now. You'll get the answers or the options that you'll see. Estimate the error committed by the neural network, add non-linearity to the perceptron output, optimize the parameter values, and activate a neural network. So you all can choose the right answer right now. I'll give you 30 seconds to do this. Let me check if you all have understood what Professor Ayan has been teaching you all. Okay, we've got 20 votes. Can you all respond to the Slido that you all see? We've got many of you all answering in the chat. That's really nice. But we would also want you all to answer in the Slido if that's possible. Okay. So we've got a clear winner, Professor Ayan. That's option number B, and that means everyone were attentive, right? So we've got a 64%, but we've got still 21% or 22% who say active, uh, activate a neural network, right? So let's quickly move on to the next quiz question that we have for you. What is the basic building block of an artificial neural network? You all see the options there: perceptron, activation function, loss function, optimization function. If you all can select the right answer, I'll give you another 30 more seconds. Wow, we've got so many of you all responding. Professor Ayan, we've got 90% who say perceptron. So that's really nice. I believe most of them are getting it right.
Yes.
Wonderful. So, we've come to the end of the session with all of this. It was really a very engaging session. Thank you to all the audience. The questions that you all were putting in, uh, and we saw your commitment, and that was really nice. Uh, Let me just quickly request my team to once again put the link in the chat for all of y'all who want to know more about the course. Just visit this link right now, and we would want you to enroll for the certification course because it will help you in every way. And a special thanks to Professor Ayan sir. The way that you've explained since the beginning till now, your slides that you had with pictures in it, when there was a question that came up, you went back to your slide to answer that question. That was really nice of you, sir. Thank you so much. And any your last final inputs to the audience that we have? May I answer?
Yeah, so it's that we are looking forward to you, and we are looking forward to have see a successful course on in this 9 8 month certification course, and expect all of you to join, and we are to start learn together, study together on this deep learning and AI/ML. So yeah,
Wonderful. So
and you
Zahid says that it was a wonderful session. He wants to thank you. Uh, Even Sripati says thank you. Shalini says great session, sir. Thank you so much.
thank you all.
Venkata says great explanation. Thank you so much. So all of them are appreciating the way that you thought. Thank you so much, Professor Ayan. And I just want to wish you all a best of luck for your future. Uh, Happy learning to all of you and have a pleasant evening. Bye bye.